Hi guys, today we do XBW. This is the XML form for bus village transformation. So let's begin. This is the tree and we want to make SPWT for this tree. So what we do first is we go with the root node, that is C, and C doesn't have any parent node, so we just write epsilon. Then we go to B, and B had the parent node C, so we write C. Then we go to A. A has the parent node B and B has parent node C. So what we do is we write A, then the path BC. So this is basically the path and this is the actual node. So we write A and BC, A and BC. Then we go to text node and write the full path ABC, write text node ABC. Then we go to B and write the full path BC, B and BC. Then we come to text node and write the full path, that is BBC, text node BBC. Then we come to A and BC, A and BC. Then similarly we fill up all the things. Then what we do is after filling up for all the nodes, we sort the whole row based on the path, and we have the following thing. So if you see, then this whole the whole row is sorted based on this column, that is the path column. So this is the epsilon, then comes A, then B, then B, then C. So what we do now is we also want to save which is the last child. So if you see this node, it is itself a last child, so we write 1. If you see this, then this is ASC, that is ASC. Where is ASC? That is sorry, something is wrong. I don't see ASC. Sorry, so this is the correct tree. There is A. Okay, fine, this is A. Okay, now we have ASC. So this is this ASC means AAC, and this node is also the last child, so we write 1. Then ABC. ABC is ABC. This is also the last child, so we write 1. So all the text nodes are last child, so we write 1 for all the text nodes. Then we come to this node, that is AC path. This is AC and this is B. And if you see, this B is not the last child. This is the first child, this is second, this is the last child. So we write 0. And this A is this A because it's AC again. So this is not the last child, so we write 0. And this B is the last child, so we write 1. Same for here, BC, this is the A, not the last child. This B is this B, not the last child. And this A is this A, which is the last child, so we write 1. Then we come here, this B is not the last child, so we write 0, and this A is the last child, so we write 1. Then we finish our bit vector. So what we see is, if you observe, then when we sort, then all the childs come together. So this is the first child, this is second child, and this is the last child because this is 1. And again we come here, this is the first child, this is second child, this is the last child. Again here, this is the first child, this is the last child. So 0, starting of the 0 determines the beginning of the child, and 1 says okay, this is the last child. Now what we do again is, we don't want to save this path, so instead of saving this whole bunch of path, we just save these positions. So A begin here, then B begins here, and C begins here. So we just save the position. A begins at 2, B begins at 8th position, and C begins at 14th position. So instead of saving saving this, we just save this, this, and this. Okay, and this is the end of BWT, XBW. Okay, now what we do next is we want to insert a branch. Say we want to insert another A with a text node. We want to insert this, so while inserting we always go from top to bottom. So what we do first is we want to insert A, so we write A and it's C. So this is the path and this is the node. So this is the path and this is the path, this is the node. And if you go here, then you will see we have to insert this AC, and this is the path section, so we have to insert here. We write C here and A here, and this is not the last child, so we write 0 here. Then what we do is we insert this. This is node and this is the path. So we insert based on this path, and here is the AC. So we write the node and AC, and this is the last child, so we write 1. Now what we do is, since we inserted here and here, so we also update this position. So what we do is, new position is 2, 9 and 15. Because we insert here, and yeah, so we insert here, then all the things get updated. So this is updated and this is updated. Now let's delete something. Let's say we want to delete this thing. So while deleting, we always go from bottom up. So first we delete this. This is equal to an ASC. This is the path. This ASC is this ASC. So we just delete this row. Then we delete A, and the path is AC, and this is this. So we delete this, and again we update the position. So this is not the valid position anymore. So valid position is 2. Then since we delete 2 things above this position, so we subtract 2 from 9. So new position is 1, 2, 3, 4, 5 and 6. So we write 6. And another is 1, 2, 3, 4, 5, 6 and 7. So new position is 7, and 8, 9, 10, 11, 12, 13, and another is 13. So this is the new position, and this is the end of this XBW.